Please remember that the complete information for the class that you are about to view is at eliθecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to eliθecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we are going to be creating a GPS tracking unit. So what we're going to be doing is we're going to be using an Arduino Uno with Wi-Fi. We're going to be using an official Arduino Ethernet shield. We're going to be using an Adafruit Ultimate GPS, and we're going to use an LCD I2C screen. And this is going to create a tracking unit we can use in order to log where something like a vehicle or even where you yourself go. So what's going to happen is out on the I2C screen, it's going to display what your current speed is. It's going to display your lat and long in degrees. Again, remember when you're dealing with the GPS world, the GPS can give you GPS coordinates, which are kind of hard to use in any practical fashion unless you're using a GPS unit, or you can actually have the GPS output your coordinates in degrees, and if it outputs in degrees, you can use that to plug the information into something like Google Maps. So we're going to be outputting your speed in miles per hour, we're going to be outputting your coordinates in degrees, and then not only that, but we are actually going to be saving all that information to a micro SD card. We are going to be creating a time stamp using the time values that you can get from your GPS unit. Using that timestamp, we are then going to plug in the speed. We're going to plug in the lat long. That is going to be saved to your SD card or your micro SD card in a TXT, essentially a text file. And then afterwards, you can pull out the micro SD card, shove it into the computer, and you can see at different times what your speed was, what the specific location was, so on and so forth. So this is the project that we're going to be doing today. Warning, warning, Will Robinson. Warning, warning. Turn back now. Turn back now. I give you permission. As the person teaching this class, as the person teaching you about Arduino, I give you permission right here and now to give up on Arduino. It's okay. Go learn Ruby on Rails. Go learn Python. Go learn Node.js. Go learn something that is not going to make you want to lose your absolute bloody mind. So what this is in regards to is when you look at the build out for this project, you may have some questions as to why I'm using the components that I'm using. Now I'm using the Adafruit Ultimate GPS, and so that's a simple GPS module. That makes sense. And then I'm using the I2C LCD screen. That, again, that's a standard part. That makes sense. But then when you look at kind of like the core of this project, you see that I'm using an Arduino Uno with Wi-Fi, and on top of that, I'm using an Arduino official Ethernet shield. That's where you might be getting a little bit confused. Like, why aren't I just simply using an Arduino Uno for this project, and why am I not simply using a standard data logging shield? Well, that's where we get into quirkiness, right? So, with me doing these projects and playing around with the Adafruit Ultimate GPS, using the Adafruit library, I may get a different result using a different library in the future, but currently using the Adafruit's official library for the Adafruit Ultimate GPS, what I have found is when I connect this Adafruit GPS to a standard Arduino Uno, that when I do, the coordinates are way off. For some reason, the latitude is massively off, like literally off by entire states. It's putting me all the way down in North Carolina. Consistently, and when I say consistently, I mean 9 out of 10 readings put me down in North Carolina for some reason. And then one out of 10 readings puts me where I'm supposed to be. So I'm not really sure why, but when I started using Arduino Uno with Wi-Fi, I was just going through doing some experiments, seeing what the differences were. And when I use an Arduino Uno with Wi-Fi, it works great. 9 times out of 10, I get the correct latitude coordinates. 1 time out of 10, curiously enough, it puts me in North Carolina. But, as I say, that's about good enough for me. So what I find is using the Adafruit library with the Adafruit GPS, I'm having to use the Arduino Uno with Wi-Fi to get the results that I'm looking for. I'm not really sure why. But one of the issues that goes along with that, if I start using the Arduino Uno with Wi-Fi, how it deals with things like SD, these data logging shields, it requires using Icsp headers. So if you look at one of these standard Arduino boards, these are the Icsp headers up here at the top, right? So you have your normal, you have your digital pins over here, you have your analog pins over here, and then you have these Icsp headers. Well, the problem is the data logging shield that I personally personally really like. This is a high let go data logging shield. Works well for many other projects. I was literally just using this for my Arduino projects, but for some reason, since this does not have those Icsp headers, the Arduino Uno with Wi-Fi doesn't like to play nicely with this. So if you're going to be using some kind of SD shield with your Arduino Uno with Wi-Fi, it's going to have those Icsp headers in order to make it work. So for this particular project, that's why I happen to be using this particular Ethernet shield. I am getting a data logging shield with Icsp headers coming in the mail, but I figured I actually made this project work, and if you've been following along with my other projects, you may have one of these Ethernet shields already in your toolkit. So basically what I decided is, okay, I've been able to make this project work this way, so I will show you how it works and go from there. I am finding that as I do more of these more complicated Arduino projects, where I think we're going to get numerous projects that more or less do the exact same thing, basically as I go through and I figure out what components actually work together to give me the results that I want. I ran into an issue again with the data logging. The Arduino didn't like my data logging modules. So this is a data logging module. So I use this for many projects. Then when I had the Arduino, for whatever reason, there's some hardware configuration in here the Arduino doesn't like, so the Arduino refused to save to this particular module. So that's why I got this data logging shield. Arduino loves this data logging shield. But, as I say, the Arduino Uno with Wi-Fi does not. And so that's where you start having to juggle all of these different components. And literally, you can have a lot of what seems to be the exact same thing, but because it's slightly different, it won't work for whatever particular project you're dealing with. So going into the future, if you're watching this chronologically, I may start doing a lot more Arduino projects that seem almost identical. The reason is because, again, like I say, when I get that Icsp shield in the mail, I will use that for this particular project and see how that works and go from there. So do remember, when you're dealing with Arduino projects, if you run into a problem and you've done a lot of troubleshooting, you've modified the code, you go out, you do a lot of searches, you cannot figure out for the life of you why something is not working how it's supposed to. Seriously, it might be a case of simply credit card troubleshooting, where simply you swipe your credit card through Amazon, buy a couple of different versions of whatever product that you're trying to use, and one of those versions may work for you. So that's the warning for today. That's why I created this particular setup, and just something for you folks to be thinking about. So with that, let's go over. I did a video when I went to the local park, basically to show you how it works in the real world at a park that's not at my house, so you don't see the GPS coordinates for my house. I also turned on the GPS unit when I was in the car, and so I can show you where it shows you what speed I was going in the car and what location I was in the car, so on and so forth. So I will show you all of that. Then I'll show you basically how to build this, and then we'll finish off with the code itself. Okay, so this is the video that I did at my local park. So basically I just have the unit sitting here on the hood of my car. You can see I have the battery pack connected to it. Again, important thing to understand about this particular project is literally if you give it a battery pack, it will keep running until the battery pack fails. So any place you have the legal right to put a logging unit, again, an employee's vehicle, your kid's vehicle, hey, your spouse's vehicle, as long as you legally have a right to do it, basically if you put it in there, as long as it's getting a GPS signal, it will track where it's going, speed, and so forth. So I have the battery connected to it. I obviously have the GPS unit connected to it. I have the I2C screen, and then up here I have the micro SD card. Basically, when I go here and I turn it on, I just want to show you that when I turn it on and there's no micro SD card, what will happen is it'll say SD card not found. Again, this is important for you to be thinking about is if the SD card is not found, do you want it to continuously loop until it is found, or do you just want to be notified that it's not found and then you want it to spit out the coordinates? I will show you how that is done in the code. This is something to be thinking about. So basically I inserted the card, I restarted it, so we see the Arduino GPS. This is just a splash screen. Once it actually boots up, we can see satellite 0, no signal, and then it's able to grab the signal. So you can see I'm getting 7 satellites right here, and I'm going at 0.52 miles per hour, and then starting to walk up to 1.5, and 2 miles per hour, and so on and so forth. We can see the lat long, so 39.43, blah, 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 and the long is negative 76.82, so on and so forth. One of the important things up here is, again, so right now, it's showing you that it's actually reading to the SD card. I'm sorry, writing to the SD card. So I have a little component in the script. If it's no longer able to write to the SD card, it'll say SD negative to give you a notification about that. Since you see that it's SD positive, you know, it's Arduino. Cross your fingers, but it should be writing to the SD card right now. Then basically as we go along, I'll stop at a second, put it down, basically pull out the SD card. So I pop out the SD card there. It's not instantaneous. It will take a couple of seconds until the SD card reads. But there you go right there. You can see it now says SD card negative. And so it's no longer seeing that SD card. Just so you know, if you're using this in the real world, if for some reason it stops reading the SD card, plug the SD card back in and then reboot your GPS unit. If you simply plug the SD card back in, it won't necessarily start writing to the SD card. So what I did is I had this unit, obviously, when I was walking in the park, and then I also put this unit in my car, and I drove with it a little bit so we can see what the miles per hour when I was driving, and I can also show you the location that I went with my car. If we go down, I can open up Finder, and I have the micro SD card here. Again, this is simply saving to a GPS log.txt file. If I double click on the GPS log.txt file, this is what we get. So we have the timestamp here. So this timestamp is actually pulled from the GPS unit itself. So you don't have to necessarily have a real-time clock with this unit. Part of the whole GPS system is grabbing the GPS time. So we can see that this is the 5th of June 2020. We can see per GPS time, and again, per GPS time, just so you know, GPS time is not necessarily what your current time is, so you may have to do some math on what your current time is, but per GPS time, this was done at 2:20. For it in the afternoon. For me, it was in the morning. You can see here where I say speed, this I was going at 0.32 miles per hour, and then we have the lat long here. So again, remember, when I'm writing out log files, I can write out the log file any way that I want. So I'm writing it out this way for 2 reasons. One is because it's easy for the user to actually be able to read. I could give this to a secretary, I could give this to a manager, and they would know what the hell they're looking at. The other thing is when I did this lat long is by putting lat long like this, one of the cool things I can do is simply highlight that, and then I can do search Google, right? So if I did lat colon and then the latitude and then long colon latitude, it might not work for me for doing something like searching Google. But by simply writing it out this way, I can simply search Google simply based off of that, and it will show me where I was. So basically it's just showing me that when I was doing this particular project, I was sitting right here at this particular park. And so that's one of the cool things about thinking about how you're actually going to be writing out your log files when you do things. So we can come down here. Again, we can see the speed. So I was at like 2.5 miles per hour, so on and so forth. But if we scroll down, we can see where I got in my car. So here I can see I got in my car, I was driving, here I was doing about 30.5 miles per hour, and so I can say, oh, okay, where was I doing 30.5 miles per hour? Or something to be thinking about, again, if this is your employee or your kid or whatever else, if you see 80 miles an hour, you can say, hey, where were they doing 80 miles an hour at? Again, I can simply highlight this, I can simply do search Google, and then it's going to spit out, and we can see here that this is where I got onto the road, and I started driving around for that 30 miles an hour. Now, one of the interesting things I can do too, so it's like, okay, well, this is where I started at 30 miles an hour. Let me click on directions. Let me click on directions here. And then what I want to do is I want to see basically where I was going, or the most likely path of where I was going, right? So this is 30 miles an hour and 36 miles an hour. So this is giving me all the records. So here I can see, okay, I was driving along till about this particular area. So one of the things I can do is I can simply copy this. I can plug that in there, and then I can simply do enter. and this will show me the path that I was actually on. So again, one of the things to be thinking about in the technology, the computer world, sometimes you can write a script, and that script will plot every single point in the path you went on. Other times, you can just put the starting point and the ending point, and Google will most likely guess for you pretty well what the path the person was going on. So what I can see here is like, oh, okay, so after the person left this park, they went down to whatever the hell's down here, and then I can go and I can try to figure that out. So this is the cool part about actually being able to spit out this information in a simple text file like this. And again, it's something to be thinking about here is when you actually write out to log files, think about how you format those log files so that the end user or even yourself can very simply use them. By simply having this lat long here in a fashion where all I have to do is simply highlight and then search Google, that makes using this particular system, relatively easy without having to create something overly sophisticated. So with that, let's go over to the workbench. I will show you how all of this is put together, and then we'll go and take a look at the code itself. So this is the project. There's really not a lot to it. Same thing that you've seen a lot of times if you've been dealing with Arduino. So we have the I2C screen here. Basically, this is plugged into the 5 volt. So the I2C screen is using the 5 volt. It's connected to the ground. It's connected to the SDA, and it's connected to the SCL over here at the top. Again, using a standards-based shield like this, the SCL and the SDA pins will go all the way through. Something to be thinking about is if you're using a different shield, not all shields have the SDA and SCL pins go all the way through. So again, be careful about that. That's one of the quirks you can run into. Then obviously I have the Adafruit Ultimate GPS module here. So this basically, the transmit and the receive, they're plugged into digital pins 8 and digital pin 7. Ground is plugged into the ground, and then with this you can actually run it off of 3.3 volts, and so for its voltage input I am simply running it off of that 3.3 volts, so I don't have to use any kind of additional breadboard. And that's really all there is to this particular project. Now the main thing here again is those Icsp headers, right? So if you can see this particular module. Again, this is a data logging module from High Let Go. I really like it. I've been really liking it all the way up until a couple of days ago. The problem with this, as you can see, it is smooth on the bottom. It does not have any Icsp headers. If we pull off this particular shield, what we can see here is we have these Icsp headers. So basically that is these headers right there. Again, they're on the Uno. They're on the modern, the version 3 of the Arduino Unos. Many times the shields without them will work fine, but for the Arduino Uno, at least as far as the SD card functionality is concerned, they need those Icsp headers. So if you're going to try to do this project with a different data logging shield, if nothing else, just make sure to get the Icsp headers, because this will not work. This will not work. They all look the same, but they don't have the right headers. So that's some of the stuff to be thinking about with the physical build. With that, let's go over and actually take a look at the code itself. Okay, so here's the code that we are dealing with. Put some notes up here just so you know. This started with the GPS software serial parsing sketch. That is the example that you get with the Adafruit library. Again, if you're going to start using the Adafruit Ultimate GPS, make sure that you start basically modifying code that has software serial in it. If we go up to File, we go to Examples. Basically we go down here to the GPS library. These are the sketches that you're going to want to modify. They give you all of these different versions up here, but this is what you're going to be using. And again, if you take a look at Adafruit's documentation, for some reason, they don't talk about the different versions of basically the same types of sketches. So whatever they're talking about, make sure to use the software serial version of the sketch. Past that, again, we're going to be using an Arduino Uno with Wi-Fi, and we're going to be using the official Ethernet shield for those Icsp headers. Again, this is one of the most important things for the SD usage. Past that, we're just simply going to go here. We're going to include the libraries for the Adafruit GPS and software serial.h. So these will be coming from that Adafruit library. Then we have the ETCG notes here. This is for the I2C LCD screen. So we are going to need to include these particular libraries. Then we're going to need to create the LCD screen. So basically we use the I2C address. So this is the default I2C address for this particular screen. Your screen may have a different I2C address, so just keep that in mind. Think about using the I2C scanner sketch if for some reason your screen fails, and this is a simple configuration to make it work. Past that, this is going to be the setup in order to make the SD card system work. So with this, we're going to be including the SPI and the SD libraries. Those should be included with your Arduino IDE. We're then going to define the SD pin, and the SD pin is going to be 4. So this is the pin that is set up in the hardware of the Ethernet shield. So different SD card shields may use different digital pins. For the Ethernet shield, the SD pin is digital pin 4. So modify this as need be. Then we're going to simply be creating a file, and we're going to be calling it log file. Past that, this is the information for connecting your GPS. And again, for the GPS, we've actually connected it to the 3.3 volt connector on the Arduino, but you could connect it to the 5 volt. You can connect it, you connect to ground. TX, transmit, is going to be connected to digital pin 8. Receive is going to be connected to digital pin 7. This is the configurations to actually get that up and running, and so on and so forth. So all this right here, this is the GPS settings we're not going to mess with. Then we're going to come down here. This is the place where we're going to be starting the LCD screen. So we're going to begin lcd.begin the screen, and we're going to say that's a 20 by 4 screen. We're basically going to be turning the backlight on. We're going to be setting the cursor, and then this is where we have the splash screen. So the splash screen is simply going to say, hey, this is an Arduino GPS unit. Again, plug in your information here, what it is, who it's by, so on and so forth. Just a splash screen. Then we're going to come down here, and I gave you 2 options. Ooh, we're getting sophisticated with our code. I'm giving you options now. So this first option here is basically says if the SD begin, if it does not begin, so we have the exclamation point on digital pin 4. So SD pin is pin 4. So if this does not begin, basically it's simply going to print out SD card not found. It's going to delay for 2 seconds, 2000 milliseconds, and then it's going to continue because it's an if statement. So this is something you want to think about. How important is it that the SD card is in the system? Especially when you're troubleshooting, you may not want to make it absolutely required for the SD card to be in the system before it boots up to do other things. So you may just want an if to tell you, hey, this is one of the failures you're dealing with, right? But basically, I've just done this here, so it'll go to the if. If the card is not found, it will then wait for 2 seconds just to tell you, but then it will continue on, so you still get the output on the LCD screen if you want it. What you could do is you could comment this out and simply go down to the while loop. So here I've done the while loop, essentially the exact same thing, but basically what this does is while you're not able to begin on that SD pin. So while it's not reading an SD card, it will simply keep printing out SD card not found. So with the while loop here, it will not go past this point until an SD card is found. With the if, it will tell you the card is not found, but then it will continue on. What you want, that's up to you. Then we're going to come down here, again, a bunch of information, serial.begin. This is all the GPS stuff, again, that we're not going to really dork with. One of the important things, if you are going to be using a serial monitor, is remember this is 115,200. So for a lot of projects, the baud rate is 9600. If you set your serial monitor to 9600, you'll just get crap. Either you won't get anything or you'll just get crap out. So if you're having a problem with the serial monitor, make sure that the baud rate is correct. Delays for 5 seconds, grab some of this information for the GPS, so on and so forth. Then we're going to come down here. Again, this continues to be all of the GPS information. Unless you know what you're dealing with, don't mess around with this. We're going to be serial printing out. So if you have your computer with you, when you're out doing your experiments, trying to figure things out, this will serial print out to the serial monitor if you want. I'm not really particularly worried about that today, but again, it'll print out what the time is. It'll print out the latitude. One of the things, again, if you do GPS latitude, this will give you the GPS coordinates in the GPS system. That's actually not very valuable. So if you do GPS.latitude degrees and longitude degrees, this will actually give you the degrees. So that's that 39 point or negative 75 point, and that is something that you can actually plug into a computer and know where you're at. Serial print out, again, speed, angle, altitude, satellites. I left all of this in so you can grab any of this information that you want to spit out onto the LCD screen or into your SD card if you want to. Again, I'm personally not that worried about this today, but you could use this to tweak the code. So, okay, so past that, we're going to come down here, and so this is where we're going to be printing out to the LCD screen. First thing we need to make sure that we do is clear the LCD screen. Remember, if you don't clear the LCD screen, it just overwrites itself, and it's all just nasty. Then what we're going to do here is on the basically on the second line, we're going to say what the speed is, and we're going to say what the speed is in miles per hour. So we're going to create a float, miles per hour. Miles per hour equals GPS.speed times 1.15. So basically the speed that you get from the GPS unit is in knots. And so apparently miles per hour is simply 1.15 knots. So then we're going to print that out. We're then going to print out the latitude as we did in a previous project. We're going to be printing out the longitude. And so this is going to be being printed out to the LCD screen. Then what's going to happen here is basically we're then going to be printing out to the log file. So what we have here is log file equals sd.open, and we're going to be opening the GPS log.txt, and we are going to be writing it to it. The next thing that we're going to do is we're going to be creating a string called timestamp, and this mess this mess is going to get us that timestamp. So what we're going to do is we're going to take all that time information we got up here, and we're going to turn it into strings, and then we're going to concatenate it, and then we're going to make that the value of timestamp. So GPS day, we're going to turn that into a string plus comma, GPS month, turn that into a string plus comma, GPS year, turn that into a string plus hyphen, GPS hour, turn that into a string plus, and then we do colon here, GPS minute, turn that into a string plus colon, GPS seconds, turn that into a string. And so basically that is what's going to give us the timestamp. So if we go down and we take a look at this nasty old timestamp here, this is how we are creating that timestamp. So if the log file is there, what we're going to do is we're going to log file print. So we're going to be printing to the log file timestamp and then whatever the value of timestamp is, right? So timestamp, that's what we have here, and then whatever the value of timestamp is. Speed, and it'll say, then it'll print the miles per hour for speed, and then I'm doing lat long as one thing. And again, so if I take a look at here, I'm simply saying lat long, and then what I'm doing is first I'm putting in the latitude, so I'm doing the latitude, then I'm adding on a comma and a space, and then I'm doing the longitude. And so what that does for me is basically it prints this out, so I can simply, again, as I've shown you before, I can simply select this and I can do a search Google here. Then we're going to go down, LCD set cursor to 17.0. So this is the very first line at the 18th position. So basically, if the log file exists, it is going to then print out their SD plus. Else, so basically it's not detecting the log file, what it's going to do is it's going to simply clear that area of the screen. So it's going to go to that 17.0 position. It's going to clear the 3 characters. To delete the 3 characters, it's going to set the position again, and then what it's going to do here is I'm simply going to do SD minus. So again, one of the things you have to be thinking about is not simply how to write to the LCD screen, but also how to erase from it. Else, so basically if there is no fix, so all of this is going to happen if there's a GPS fix. So if the GPS unit can actually detect something, it's getting the lat long, all of this will serial print out, all this will LCD print out, and then all the log file information will print out. Basically else, if it's not detecting a signal, then it will simply say no signal. Past that on the LCD screen, it's then going to say how many satellites that it is seeing, and that's what you can see in the video that I showed you. So again, I guess that's another important thing just to point out here. All of this printing out is dependent on the GPS actually fixing its location. So it will not print out this information to the serial monitor. It will not print out this particular information, the speed, the lat, the long, to the LCD, nor will it print out to the log file if it's not getting a GPS fix. I put the log file in this particular area of the script just so you're not writing to the log file when you're not getting a fix. You don't want thousands and thousands and thousands of lines of Basically nothing, or at least I don't. Maybe you do. And anyways, that's basically how this code works. It's one of those things, just kind of go through it, take a look at it, modify things where you want to modify things. But overall, I think if you step through it, it's relatively simple. And with this, the important thing is it will then write out to that SD card for you. You can then pop out the SD card, put it into a computer, and see where people have gone, what speeds they were going, so on and so forth. So that's how this particular project works. So just to reiterate, legally authorized, legally authorized, legally authorized. Have I said legally authorized? I just want to make sure that's been said. Nobody can say, Eli didn't say anything about legal authorization. I have said legal authorization about 10 times now. So basically, this is how you can create a GPS tracking unit. Not only will it print out to the LCD screen so you can see what's going on, but it will actually save to a GPS log.txt file. It will say what the speed is. It will say the date and time. It will say the lat long, so on and so forth. So again, if you're using this for your particular project, this is a good little way to start playing around with the GPS, seeing what the GPS can do, because again, one of the important things whenever you're dealing with Arduino projects is the output itself isn't necessarily the most important thing for you to understand. The important thing to understand is that you can turn these values into variable values, and then you can test against them, right? So as soon as I can turn a speed into a value, I can then test against that value and then have other things occur. So basically, if the speed of a vehicle goes above 70 miles an hour, I could have a red LED turn on. Or if I had like an LTE shield, basically a shield that allows you to connect to a cellular network, something like that, if the speed goes over 70 miles an hour, possibly I could have it send information to a server so that somebody then gets an alert. So again, imagine if you have a fleet of vehicles, you want to make sure the people in your vehicles are driving safely. So what you could have, if you had an LTE shield, as soon as the speed goes above 70, that could trigger an event for basically your Arduino to send a message to the server. The server could then parse that message, and then from there send out an email, send out an SMS, put something on a display, so on and so forth. So that's one of the things I really want you to be thinking about with these particular projects. But with this, the cool part is, again, you can save to the SD card, and as I showed you with that, I'm giving you the timestamp, I'm giving you the speed, I'm giving you the lat long. Again, something to be thinking about when you create your own projects is to be thinking about how you format that data file, right? How you format that data file is completely up to you. You could actually format that data file as a full HTML web page, right? I could, if I want, oh boy, if I wanted to, I don't want to go to it, but I could actually print it out. And so I could print it out with hrefs, and I could actually print it out with like embeds and all that type of thing. So basically I could open this in a web browser. Instead of saving to a .txt file, I could save to a .html file, write out all the additional HTML code whenever it's printing something out, and be able to then present the end user with like an HTML web page, which may give you information. So that might be something a little bit more sophisticated, something a little easier for an end user to deal with. On the other hand, if all I want to do is take this information and dump it into a SQL server, or dump it into a database server, then if I know what all the cells, the records are supposed to be, I may just simply use a CSV format. So I may simply do, here's a timestamp, comma, here's a speed, comma, here's a lat, comma, here's a long comma, here's blah, blah, blah. And basically what I could then do is pull the SD card out, shove it into my server, upload that, and then the server would parse and simply dump that into a table in the database. And then once it's in a table in the database, then whatever application you have to read that table could then do something with it. So those are some of the things to be thinking about with a particular project like with this. Again, we're getting that place in the Arduino world where there's a lot of stuff that you can do with Arduino, but you do have to make sure that you purchase the right equipment. Again, I have so many at this point, I have so many products that basically do the exact same thing, but they do it slightly differently. And so when you're looking at this particular project, the reason that I'm using the Arduino Uno with Wi-Fi is because with this, I predominantly get the right values for coordinates. Then why am I using the Ethernet shield for this? I'm using the Ethernet shield because that has the Icsp headers that I need in order to actually be able to write to an SD card from an Arduino Uno with Wi-Fi. So that's one of the things too. If you're looking at this particular project and you're saying, oh, I don't have a particular component or I want to modify it a little bit, just realize certain hardware works and other hardware doesn't. And so you may have to do a little mixing and matching and troubleshooting to figure out what's going on. One of the things that I will say is that if you're looking at that log file, when I was showing you the log file, you will see that there were still errors in the coordinates. Every once in a while, it did do the whole 98 or something coordinate for the longitude. And so that is something that you're going to have to be thinking about with your code, especially if you're going to be uploading this stuff to a server. So if you're sending this data to a server and then having the server parse, one of the things you're going to have to think about is basically how are you going to eliminate obviously erroneous information, right? So if the longitude is supposed to be, negative 76 point blah, 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 and then it's 98, that's basically putting me like a quarter of the way around the world. That's obviously wrong. So one of the things you're going to have to be thinking about is if you're going to be uploading this to a server so that the server can run whatever, algorithms and wants to run off of it, one of the things you're going to have to be thinking about is how can you eliminate obviously incorrect values where something is, again, states. I mean, again, we're not talking about a couple of streets off or even a couple of counties off. We're talking about states or countries off, right? You're going to have to be thinking about how to parse those values and make sure the data that you're receiving is as accurate as you need it to be. That's one of the fun things with being a technology professional. Something for you to think about. Also, if you're going to be putting this onto something like an autonomous vehicle, you do have to put some kind of limiting mechanism in there so that if it does get an erroneous reading, it doesn't do something massively stupid, right? Because imagine you have an autonomous aircraft and it's flying along and it's flying along and it's doing its path and everything's great, and then all of a sudden it gets an erroneous reading that basically puts it 100 miles off course. That autonomous aircraft is then it will then maneuver based off of however you've coded it to maneuver, and it damn near may try to take a right angle turn to get to the location it's trying to get to, which may cause its own kind of problem. So again, it's very important to be thinking about with the GPS, how do you get rid of those erroneous values? And it's just something to be thinking about when you put into the script. So, as always, I enjoyed doing this class. I look forward to seeing you at the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.